Welcome to the Deep Dive, the show that takes the stack of material you've shared with us and turns it into immediate, actionable knowledge.
Hey there.
We are diving headfirst into a field that is undergoing a complete and utter revolution. I mean, it is fundamentally changing how we understand and treat a chronic global disease, obesity.
That's absolutely right. And for anyone, struggling to keep track of the seemingly weekly announcements coming out of clinical trials, this deep dive is a necessary shortcut.
It really is.
We're focusing today on obesity pharmacotherapy, specifically this extensive pipeline of new medications that are delivering weight loss efficacy approaching, and in some cases, truly matching the results we've previously only seen with major invasive bariatric surgery.
Okay, let's unpack this and set the stage. We've reviewed the analysis of this massive pipeline of treatments, focusing particularly on those based on enteropancreatic hormones. But before we get into the new molecular cocktails, let's frame the mission and just acknowledge the stakes here.
Our mission today is to analyze what this new era of care really means for you, the learner. And the starting point has to be defining the problem. Obesity is not a moral failing. It is a complex, chronic disease characterized by excess adiposity that demonstrably impairs health.
And it affects a staggering number of people.
A staggering number. We're talking about 650 million people worldwide. That number alone it's just hard to comprehend.
And the risk profile attached to that chronic condition is massive.
It is. I mean, obesity dramatically increases the risk for multiple severe complications. Type 2 diabetes, cardiovascular disease, obstructive sleep apnea, or OSA, and a growing crisis that we're seeing known as metabolic dysfunction-associated steatotic liver disease, or MSLD. These are life-altering conditions, and historically, our treatments just haven't risen to meet the challenge of such a pervasive chronic disease.
So let's look at the past, because that really defines the clinical gap we are trying to close now.
Yeah.
Historically, what was the first line of defense, and, well, how effective was it?
The cornerstone, and it's still a vital part of management, is lifestyle interventions. So diet, exercise, behavioral changes. These are crucial for overall health and maintenance.
Of course.
But even the most intensive interventions typically only yield up to about 10% mean weight loss. And here's the brutal reality, which is critical for you to understand. 80% of that weight loss is expected to be regained over 5 years.
80%?
Yeah.
Why is the regain rate so high? It just seems like a cruel biological joke.
Yeah.
You know, it's not just about willpower.
Absolutely not. It is entirely physiological. When you lose a significant amount of weight, the body launches this massive counter-regulatory response. Two main forces drive this chronic physiological hunger.
Okay.
First, you experience a persistent lower resting metabolic rate. Your body just burns fewer calories doing nothing. And second, you have a relentless increase in appetite mediated by long-lasting changes in hormones like ghrelin, which increases, and satiety hormones, which decrease.
So the body basically interprets weight loss as starvation.
Exactly. It thinks it's starving, and it actively, aggressively fights to restore the lost weight.
So we have lifestyle interventions hitting that 10% weight loss ceiling, which the body then tries to reverse. On the other, far more effective side of the spectrum, you have bariatric surgery.
Surgery is the long-established gold standard for efficacy. It results in 25 to 30% mean weight loss and, crucially, long-term weight maintenance. But it's just not a scalable public health solution.
Right.
Millions who need this level of intervention won't receive it because of resource limitations or, more commonly, patient hesitation regarding the perceived risks of post-operative complications. Many people just opt against it.
This means the clinical gap used to be enormous. You've got a 10% maximum pharmacotherapy result versus a 25 to 30% surgical result. That gulf only started to shrink slightly with the last generation of drugs.
Precisely. The approval of the GLP-1 receptor agonist, specifically subcutaneous semaglutide 2.4 milligrams once weekly, changed the entire landscape. It achieved 15 to 17% mean weight loss, significantly closing that gap.
And we even have evidence of cardioprotection with this class of drug, which moves it beyond just a weight loss treatment.
Absolutely. But still, 17% is not 25%. That remaining difference was a significant unmet need gap that this new pipeline of combination agents is designed not just to shrink, but to close entirely, matching surgery without the invasive risks.
Okay, let's jump into part one then. The GLP-1 foundation and the move to oral agents. It's clear that GLP-1 is the foundational molecule. It's the backbone of almost everything effective that's coming down the line. Before we discuss the new administration methods, let's quickly review what GLP-1 RAs actually do in the body.
Sure. GLP-1 arrays, or glucagon-like peptide-1 receptor agonists, work by activating the GLP-1 receptor, which is widely distributed across the brain, pancreas, and gut. Their actions are multifaceted.
Okay.
In the gut, they delay gastric emptying, which contributes to that feeling of fullness. In the brain, they act on hypothalamic centers to increase satiety and reduce overall food intake.
And what about metabolically?
On the metabolic front, in the pancreas, they stimulate insulin release and inhibit glucagon secretion, but, and this is key, both strictly in a glucose-dependent manner. This means they don't typically cause dangerous drops in blood sugar in people without type 2 diabetes.
That cocktail of effects makes them incredibly powerful. But the current standard subcutaneous semaglutide 2.4 milligram is an injectable. If we're aiming to treat 650 million people globally, requiring them to inject themselves every week is a major barrier.
A huge barrier to acceptance, adherence, and especially long-term compliance.
So what's the pipeline doing to address this injectable barrier?
The industry response is pretty robust, and it comes in two main flavors. First, creating higher dose, more effective oral formulations of known injectable compounds. And second, developing entirely new oral small molecule non-peptide agonists.
And the goal is just convenience.
The core engineering goal is simple: improve convenience, acceptance, and adherence to make lifelong treatment, that long-duration therapy we're talking about, actually feasible for millions.
Okay, let's start with the one we know. Oral semaglutide, but in a new high-dose 50 milligram formulation, not the original 14 milligram. What did the phase 3 OASIS 1 trial show for people with obesity but without type 2 diabetes?
The results were genuinely compelling. They showed that an oral formulation could achieve the same weight loss territory as the injection. Over the 68-week trial, participants combining the oral semaglutide of 50 milligrams once daily with a lifestyle intervention achieved a mean weight loss of 17.4%.
Wow, 17.4%. And the placebo group?
Just 1.8%. So this immediately positions the high-dose oral agent as a powerful competitor to the injectable 2.4 milligram a dose for overall weight management.
So for the general obesity population, the efficacy definitely holds up. What about people with type 2 diabetes, where the drug has that dual job of controlling blood sugar and driving weight loss?
Right, so the Pioneer Plus trial assessed people with type 2 diabetes. The oral semaglutide 50 milligrams resulted in 9.8% weight loss. Now that's lower than the 17.4% in the non-diabetic population, which is a common trend across all these drugs.
It is, yeah.
But it was still significantly better than the 5.4% weight loss seen with the original 14 milligram oral dose over the same 68-week period.
And what about the blood sugar control?
Perhaps even more clinically important for this population, it reduced HbA1c by a substantial negative 2.1% compared to negative 1.3% with the 14 milligram dose.
That is a marked improvement over the lower dose. But here's the challenge, right? The administration requirements for oral semaglutide are notoriously strict. It's not just popping a pill with your morning coffee.
That is the crucial adherence hurdle.
Yeah.
Oral semaglutide uses a proprietary absorption enhancer to facilitate uptake through the gastric mucosa, which is a very precise process.
They got to follow the rules exactly.
Exactly. To maximize absorption, it must be taken first thing in the morning with only 120 milliliters of water. That's a very small amount. And then the patient must fast completely for 30 minutes before any meal or even any other medication.
For busy people, that specific fasting regimen can be highly challenging. It's a known barrier to long-term adherence.
It is.
Which brings us to the next generation of oral agents, specifically designed to bypass that adherence challenge. Let's talk about orforglipron, a non-peptide GLP-1 RA.
Orforglipron is truly novel. It's a small molecule, non-peptide GLP-1 RA that can be taken once daily orally. And because it's a small molecule, it interacts with the receptor in a slightly different manner.
What's the practical advantage of that?
Well, the key functional point, the competitive advantage, is that it does not require taking it in a fasting state. This makes it far less burdensome to administer than oral semaglutide.
So what kind of weight loss efficacy did this non-fasting, less burdensome pill achieve?
The phase 2 trial, which involved multiple dose ranges up to 45 milligrams over 36 weeks in people with obesity, showed strong dose-dependent weight loss reaching up to 14.7%. That's compared to a minimal 2.3% with placebo.
And in the T2D population.
For those with type 2 diabetes, the results were just as encouraging. 48% of participants achieved at least 10% weight loss after just 26 weeks on the 45 milligram dose. And the mean HbA1c change was substantial, up to -2.1%.
So we have an effective oral agent that hits that 15% efficacy range without all the strict rules.
Exactly. It's approaching injectable efficacy without the injection and without the fasting.
Now let's look at the third entrant in the oral race, danuglipron, another oral non-peptide GLP-1RA. Where did this one land?
Danuglipron is also a G protein-biased GLP-1RA. Its phase 2 trial in people with obesity showed very respectable weight loss, up to 11.7% with doses between 40 and 200 milligrams, compared to a small 1.4% weight gain with placebo over 32 weeks.
That sounds promising, but this is where the conversation shifts from pure efficacy to feasibility, right?
This agent, unfortunately, ran into some major tolerability walls.
That's right, and this case study is crucial for you to hear. While the efficacy was there, the critical challenge for danuglipron's initial formulation was the unacceptably high discontinuation rate. The rates were greater than 50% across all active doses.
50%.
Compared to about 40% with placebo, and this was overwhelmingly due to gastrointestinal adverse events, or AEs. Wait, if the efficacy is there, but more than half the people quit due to GI issues, does this drug even matter? How can the manufacturer possibly pivot and fix that tolerability problem?
You hit the nail on the head. If half the people quit, it fails the real-world utility test. Because of these high rates, the twice-daily formulation is being abandoned.
So they're starting over.
The manufacturer is now focused exclusively on developing an improved once-daily formulation, aiming specifically to address the high peak plasma concentrations that likely drove those intolerable GI-AEs. Even in the T2D population, the high doses led to 22 to 34% of participants discontinuing. It just proves that tolerability is often more important than efficacy in chronic therapy.
So efficacy is achievable orally, but only if the formulation is gentle enough for chronic long-duration use. Let's finish part 1 with a quick safety snapshot of the oral GLP-1RAs overall.
The general safety profile is pretty consistent across all these oral agents, and it mirrors the injectables. Most AEs are mild to moderate gastrointestinal issues, nausea, vomiting, diarrhea. They usually diminish over time once a stable dose is reached.
But you mentioned a weirdly specific side effect anomaly with the high-dose oral semaglutide.
Yes. There was a specific anomaly noted in the OASIS-1 study, that's the trial in people without diabetes, where 13% of participants on oral semaglutide 50 milligram experienced altered skin sensation events.
Altered skin sensation.
Compared to just 1% in the placebo group.
That's a fascinatingly specific side effect. Is that dangerous, or is it merely curious? Does it suggest the absorption enhancer is causing some kind of systemic effect we didn't predict?
It's curious more than dangerous. The source notes the events were generally mild to moderate. They primarily occurred during the dose escalation phase, and they resolved without requiring treatment discontinuation.
But why only in that group?
Well, what makes it important is that this AE was not reported in the type 2 diabetes trials using the same dose, nor was it reported with the injectable semaglutide 2.4 milligrams. So this suggests a unique interaction specific to the oral formulation in the non-diabetic population, and its precise cause will need more exploration.
So what are the discontinuation rates for the successful oral agents?
Generally, they're manageable, about 6 to 13% for oral semaglutide, 50 milligrams, and between 10 and 21% for orforglipron.
Okay, so the key takeaway from part 1 is that the oral agents are closing the injectable gap, hitting that 15 to 17% weight loss mark. But the next evolution, the dual and triple agonists, that's where we truly start to move into surgical territory.
Exactly. Welcome to part 2, the synergy revolution. We established that 15 to 17% ceiling for single GLP-1 agonism. The scientific community realized they needed a different angle, and that angle was combination therapy.
Why combine these enteropancreatic hormones? What's the underlying biological theory that stacking hormones works better than just maximizing one?
The entire concept is supported by the mechanism of bariatric surgery itself. Surgery is effective not just because of physical restriction, but because it leads to dramatically increased postprandial levels of multiple hormones, GLP-1, GIP, glucagon, and amylin.
Okay.
By combining synthetic analogs of these hormones, we aim to leverage different but complementary pathways, enhancing or complementing GLP-1's effects to achieve superior weight loss while potentially minimizing adverse effects.
Let's start with the dual agonists that catalyze this entire shift, tirzepatide. This targets both the GLP-1 and the GIP receptors.
Tirzepatide received FDA approval for chronic weight management in November 2023, and that date truly marks the start of this new era. It is administered once weekly subcutaneously and is a unimolecular dual receptor agonist. One molecule hits two receptors.
And the efficacy data here is simply unprecedented for a pharmacotherapy. For you, the listener, this is the data that redefined what was possible with the drug.
The data comes from the foundational SURMOUNT program. In SURMOUNT-1, which studied people without diabetes, the maximum 15 milligram dose induced a staggering mean weight loss, ranging from 16% up to 22.5% at 72 weeks.
22.5%.
To put that into perspective, for a patient weighing 250 pounds, that's over 56 pounds lost in less than a year. This isn't just closing the gap with surgery. For many, it is surgery without the knife.
And crucially, the sources noted that participants showed no sign of their weight plateauing at the end of the 72-week trial.
That is a critical detail. It suggests the potential for even further weight loss with longer-term use, pushing the envelope even closer to that 30% mark previously only achieved by invasive procedures.
How did it fare in the population with type 2 diabetes, who, as we said, generally show a blunted response to these medications?
In SURMOUNT-2, which focused on people with obesity and type 2 diabetes, the mean weight loss was still remarkably high, up to 15.7% at 72 weeks, compared to 3.3% with placebo.
And for glucose control.
We also look at the SURPASS trials focused purely on type 2 diabetes. 40 to 69% of participants achieved at least 10% weight loss with the higher doses, which is excellent glucose and weight control combined.
Beyond the scale, what about the non-weight loss benefits for metabolic health?
Oh, they are profound. In a sub-study of SURPASS-3, tirzepatide resulted in a relative reduction in liver fat content by an impressive 40 to 47%.
Wow!
That's compared to just 11% with insulin glargine over 52 weeks. This demonstrates a specific therapeutic benefit for liver health that goes way beyond mere calorie restriction.
This new class of drugs delivers incredible results, but it also provides crucial evidence that obesity must be treated as a chronic, continuous disease. And the SURMOUNT-4 weight maintenance trial drove this point home dramatically.
SURMOUNT-4 is vital information for anyone listening, especially regarding the required commitment. The trial had a 36-week lead-in where everyone took tirzepatide and achieved 21.1% mean weight loss. Then they were randomized. Participants who continued on tirzepatide managed an additional 5.5% weight loss from that point. Meanwhile, the placebo group, they experienced a mean weight regain of 14%.
That 14% regain on placebo after only 36 weeks off the drug is a stark, almost painful reminder. It underscores that when the medication that corrects the underlying physiology is removed, the body's weight-promoting defenses just roar back to life.
Exactly. It confirms that obesity treatment, for most people, requires lifelong, continuous management, similar to how we manage hypertension or high cholesterol. It is not a 72-week fix.
And SURMOUNT-3 gave us insight into sequential treatment. What happens if patients first undergo intensive lifestyle changes? Is the drug still as effective?
It showed a powerful additive effect. Adults with obesity first achieved a mean weight loss of 6.9% through a 12-week intensive lifestyle intervention. When tirzepatide was added, they achieved an additional 18.4% weight loss.
Compared to the placebo group?
The placebo group actually regained 2.5%. So this demonstrates that pharmacotherapy is highly effective whether you use it first line or as an escalation step after lifestyle modification.
Let's address the mechanism nuance here. Tirzepatide is described as an imbalanced and biased dual agonist. That's technical language. What does it mean functionally for the patient?
Right. The core mechanism is interesting. Tirzepatide has a slightly lower affinity for the GLP-1 receptor compared to native GLP-1, but comparable affinity for the GIP receptor.
And the bias part.
The technical jargon about being an unbiased GIP agonist versus a GLP-1 RA with low efficacy for recruiting beta-arrestin means this: the drug is engineered so that the GLP-1 effect is functionally tailored, maybe to minimize certain side effects, while fully leveraging the unique benefits of GIP activation. It creates a specific profile that drives superior weight loss.
Now, here's where it gets really interesting and, well, counterintuitive. We just praised tirzepatide for activating the GIP receptor. But we also have evidence suggesting that blocking GIP receptors might also be effective for weight loss. That sounds like a contradiction.
It is a high-risk, high-reward, counterintuitive approach. GIP antagonism is being explored because some preclinical studies suggest that the complex nature of the GIP receptor means that long-term agonist exposure might eventually lead to desensitization.
So blocking it might be a different way to get a benefit.
Blocking the GIP receptor in combination with GLP-1 agonism could provide a totally novel mechanism.
And the specific drug here is AMG 133. It's a monoclonal antibody that acts as a GIP antagonist while simultaneously activating the GLP-1 receptor. What did this unique molecule yield in its early data?
The phase 1 trial showed promising dose-dependent weight loss up to 14.5% by day 85, which is rapid. But what was truly notable, given the chronic nature of this disease, was that the weight loss was maintained for a few months after the last injection.
That's a huge deal for adherence.
It's fantastic for adherence. It suggests a potentially longer-lasting effect than current weekly injectables. Phase 2 trials are ongoing, and this represents an important hedging strategy. If the dual agonist pathway hits a ceiling, this antagonist-agonist approach offers an alternative mechanism to explore.
That GIP-GLP-1 combination clearly took us into surgical territory. Now we move to part 3, expanding the toolkit even further, incorporating glucagon and amylin coagonists. If dual is great, how do we push past 22.5%?
By adding a third major metabolic hormone, glucagon. Glucagon is secreted from pancreatic alpha cells and is primarily known for raising blood sugar. But glucagon agonism offers two distinct and crucial benefits in the context of weight management.
Okay, what are they?
First, it reduces food intake, similar to GLP-1, but most importantly, it increases energy expenditure, it revs up your internal metabolism, and promotes hepatic fatty acid oxidation.
Increasing energy expenditure is the holy grail. It directly addresses that metabolic slowdown caused by weight loss. And why does promoting hepatic fatty acid oxidation matter clinically?
It makes glucagon coagonists particularly beneficial for complications involving the liver, like MASLD or MASH metabolic dysfunction-associated steatohepatitis. The specific mechanism of burning fat in the liver provides a targeted therapeutic advantage beyond general weight loss.
The increase in energy expenditure sounds like a perfect solution. But is there a potential physiological drawback to long-term glucagon agonism?
There is a critical physiological concern that the source materials flag, and it's related to the quality of the weight loss. Long-acting dual or triple agonists targeting the glucagon receptor have demonstrated a marked suppressive effect on circulating amino acids.
And the worry there is?
The worry is that this could lead to potential lean muscle mass loss, or sarcopenia risk. And that loss of muscle mass would, ironically, reduce your overall resting energy expenditure over time. Future research really must clarify this effect, especially in older populations.
This forces us to ask, is the weight loss good quality weight loss? That's something we'll discuss more in part 4. But first, let's look at the dual GLP-1 and glucagon coagonists, starting with survodutide.
Survodutide is one of the more advanced GLP-1 glucagon molecules, now in phase 3 trials. Its completed phase 2 trial achieved a dose-dependent mean weight loss up to 18.7% compared to 2% with placebo in people without diabetes.
That's high efficacy, hitting tirzepatide's lower range. But what about that tolerability concern we mentioned earlier?
Well, it suffered from the same issues that danuglipron initially faced. It had high discontinuation rates due to AEs, ranging significantly from 20 to 29% across the dose groups.
So almost a third of people dropping out in some cases.
Right. These discontinuations were primarily due to GI issues during the rapid escalation phase. The developers are hoping a much more gradual dose escalation in phase 3 can mitigate this. But on the positive side, survodutide has FDA fast-track designation for MNH, strongly indicating its unique liver benefit.
Next, mazdutide. This is an oxyntomodulin analog hitting both GLP-1 and glucagon receptors.
Phase 2 data from a Chinese population showed weight loss up to 11.3% with the 6 milligram dose. More recent data for a higher 9 milligram dose suggests a placebo-adjusted weight loss of 15.4% after 24 weeks.
And the safety profile.
This is what truly differentiates mazdutide. In those phase 2 trials, discontinuation rates due to AEs were reported to be exceptionally low, ranging from 0 to 2%.
Wait, 0 to 2% discontinuation due to GI issues. Then the massive competitive advantage. If the efficacy is solid in phase 3, that tolerability profile could make it the preferred choice for patients who struggle with nausea on other agents.
Absolutely. Tolerability is the gatekeeper of chronic therapy. Now, efinopegdutide is another dual GLP-1 and glucagon agonist. In its obesity trial, it achieved up to 11.8% weight loss, which on the surface is lower than its competitors.
But its benefit, like survodutide, seems highly specialized and focused on a specific comorbidity.
Precisely. In people with type 2 diabetes and MASLD, afinopegbutide demonstrated superior liver fat reduction despite having similar overall weight loss compared to semaglutide.
How much superior?
The 10 milligram dose reduced liver fat content by an incredible 72.7% versus only 42.3% with semaglutide 1 milligram. This profound, specialized liver benefit has led to its clinical development shifting heavily toward a MANS treatment.
That's a great example where patient selection will be key. If a patient's primary comorbidity is MASLD, this might be the superior first choice, even if the weight loss number is slightly lower. Finally, pemvidutide, another GLP-1 glucagon agonist.
Pemvidutide achieved a mean weight loss up to 15.6% at 48 weeks with its highest dose. However, it also wrestled with tolerability, seeing high discontinuation rates. 20% of participants on the 2.4 milligram dose dropped out due to AEs, primarily nausea and vomiting. It, too, showed significant specialized liver benefit.
The efficacy is clearly rising across the board, but tolerability and specialized benefits are quickly becoming the key differentiators among these GLP-1 glucagon agents.
No, we reached the apex of efficacy data so far. The triple agonist, retatrutide. The logic suggests 3 receptors must be better than 2. Retatrutide is the current frontier. It's a triple agonist targeting GLP-1, GIP, and glucagon receptors. The preclinical models already suggested superior results, attributing this to the unique trifecta. Reduced calorie intake from the GLP-1 GIP axis, combined with that increased energy expenditure from the glucagon axis.
This is where we stop closing the gap with surgery and officially enter surgical territory. What were the headline results from the Phase 2 trial?
The Phase 2 study in people with obesity without type 2 diabetes was transformative. It led to a spectacular dose-dependent weight loss up to 24.2% at the end of the 48-week treatment period.
24.2%.
This is a mean weight loss in under a year that was previously unthinkable outside of an operating room.
A 24.2% mean weight loss in less than a year. To reinforce that, for a patient starting at 300 pounds, that's losing over 72 pounds. What proportion of patients hit the highest targets? Because that's what truly shows the power of the drug.
This is the specific triumph and the most impressive finding. Weight loss of 25% or more occurred in 36 to 48% of people taking the highest doses.
So almost half the people on the highest dose lost a quarter of their body weight.
In comparison, 0% of people on placebo achieved that result. And the results were slightly more pronounced in female participants and those with a higher initial BMI.
Were the metabolic benefits equally strong in people with type 2 diabetes?
Yes. In people with T2D, retatrutide resulted in substantial reductions in both body weight and HbA1c. The maximum dose achieved an HbA1c reduction up to 92.2%, which is truly powerful.
And the liver benefits.
In a MENA-LD subgroup, the fat content normalized in approximately 90% of people receiving the highest doses, demonstrating profound multi-organ metabolic improvements.
And what about the safety profile for this powerful triple agonist? Was it manageable?
It was consistent with the class. Transient and mostly mild to moderate GI symptoms were the most frequently reported AEs, and notably, these occurred more frequently in the group started on a higher 4 milligram dose compared to the 2 milligram starting dose.
Which reinforces that major recurring lesson for this entire pipeline.
Exactly. Gradual titration is the single most important factor for improving tolerability and reducing discontinuation rates in these high-efficacy drugs.
To round out the hormone discussion, let's cover the last synergistic hormone, amylin, in the form of the dual agonist CagriSema.
Amylin is co-secreted with insulin from pancreatic beta cells and acts on brainstem receptors to reduce food intake and improve glucose metabolism. Its unique advantage relative to the glucagon coagonists is crucial for you to understand.
Let's simplify that advantage. Amylin is special because it shuts down your appetite without slowing down your metabolism, right?
That's the functional takeaway. The reduction in food intake with amylin is not accompanied by the expected decrease in energy expenditure. Since GLP-1 primarily focuses on intake reduction, amylin makes an ideal complementary partner.
So the combination is CagriSema. What synergy did the clinical trials show?
CagriSema is cagrilintide, a long-acting amylin analog, combined with semaglutide 2.4 milligrams. A Phase 1b trial showed up to 17.1% weight loss with CagriSema compared to only 9.5% with semaglutide alone. That strong difference suggests a true synergistic effect.
meaning the drugs are more effective together than their individual parts would predict.
Precisely.
And the synergy held up in the type 2 diabetes population, I assume?
It did. A phase 2 trial in people with type 2 diabetes showed 15.6% weight loss with cagrilintide compared to only 5.1% with semaglutide alone. The HbA1c reduction was also superior. This dual approach offers another powerful tool, especially for those who might not tolerate or respond adequately to the other pathways.
Moving into part 4, we have to discuss agents that focus on improving the quality of weight loss, not just the quantity. Because if you achieve 25% weight loss, but a significant portion of that is metabolically important lean muscle mass, that's suboptimal. This is where non-hormonal therapies like bimagrumab come into play.
This is a breakthrough in body composition management. Bimagrumab is a human monoclonal antibody that bypasses the hormone axis entirely. It stimulates skeletal muscle growth by blocking the activin type 2 receptor, which normally inhibits muscle growth.
So it's actively trying to solve that problem of sarcopenia risk we flagged with the glucagon agonists. What was the unique, potentially game-changing benefit seen in its phase 2 trial?
The results were genuinely radical for body composition. In a phase 2 trial, bimagrumab was associated with a marked reduction in fat mass 20.5%, while simultaneously increasing lean mass by 3.6%.
So they were losing fat while gaining muscle.
Exactly. This is compared to a small 0.8% loss of lean mass in the placebo group. While the total weight loss was modest at negative 6.5% because they were trading fat for muscle, the change in body composition was profound.
That truly addresses the core concern of bad weight loss. Why is preserving lean mass so vital, not just for aesthetics, but for long-term health?
Lean mass muscle is the primary engine of your metabolism. Losing it contributes directly to that lowered resting metabolic rate we discussed at the start, which is the body's primary mechanism for weight regain.
So by preserving or even building muscle while dropping fat.
Bimagrumab could potentially make long-term weight maintenance easier and improve metabolic health far more efficiently than just losing weight.
This makes bimagrumab an incredibly attractive option, especially for treating sarcopenic obesity.
Right.
What are the market implications? Will the future standard of care require combining a high-efficacy drug like tirzepatide with a body composition modifier like this?
That is the direction the science is heading. The current thinking is that to achieve truly optimal outcomes, maximal weight loss and maximal metabolic health, you need a combination. We know there's a phase 2 trial underway specifically combining bimagrumab with semaglutide, aiming to achieve both the high overall weight loss from the GLP-1RA and the muscle preservation from the ACT-RII inhibition.
That could become the gold standard for quality weight loss. We should also briefly mention other non-hormone pathways being explored, like GDF15 analogs.
Right. GDF15 is a stress-induced cytokine that reduces food intake via the central nervous system. Its discovery as a therapeutic target came from observing that elevated GDF15 in patients with certain tumors is correlated with drastic unintentional weight loss. Early phase trials are ongoing, though the initial efficacy has been more modest.
Okay, we surveyed the landscape from orals achieving 17.4% to the triple agonist hitting 24.2%. These aren't just new drugs. They represent a fundamental change in clinical capability. The clinical implications of this new era are vast and require a complete system change. Let's discuss the shift in treatment targets first.
The efficacy we're seeing, 15 to 25% mean weight loss, allows clinicians to treat obesity toward individualized treatment targets. This is a profound conceptual shift. Previously, the goal was merely any weight loss. Now, we can manage obesity like other chronic diseases like type 2 diabetes or dyslipidemia, where targets are tailored to the individual's needs. A patient with severe MASLD might aim for 15% weight loss on a glucagon co-agonist, while a patient aiming for remission of sleep apnea might target 25% on a triple agonist.
But despite these unprecedented high mean weight loss numbers, we still have to be realistic and acknowledge the heterogeneity of response. These drugs don't work perfectly for everyone.
This is a persistent clinical challenge. We must be transparent that around 10 to 30% of participants, especially those with type 2 diabetes, still achieved less than 10% weight loss, even on the highest doses.
And tolerability is still an issue.
It is. 5 to 15% of participants stopped treatment due to AEs with most agents, and this was even higher, up to 20 to 30% with some of the rapid titration schemes.
So even with this explosion of effective therapies, a substantial minority of patients may not tolerate or achieve their goal with a first-line drug. This speaks directly to the need for choice.
Exactly. This heterogeneity necessitates having multiple effective mechanisms and routes of administration available. If a patient fails or can't tolerate tirzepatide, a clinician can pivot to an oral agent like orforglipron, or switch to a glucagon coagonist for the liver benefit, or even consider combining medications.
We've already spent time on it, but we need to reinforce the message on long-term commitment. This isn't a quick fix, it's a chronic treatment for a chronic disease.
The evidence is conclusive and unyielding. Obesity is chronic, and if the treatment is stopped, weight regain is highly likely, diminishing the health benefits. The SURMOUNT-4 trial provided explicit evidence that treatment must be continuous.
So it's likely lifelong.
It is, which requires significant research into maintenance strategies. Can we use lower doses or less frequent dosing to maintain weight cost-effectively over the long term?
Speaking of long-term data, the preceding generation of drugs is vital for predicting the long-term viability and safety of this new, more potent pipeline. Let's look closely at the semaglutide 2.4 milligrams SELECT trial data, which gave us a 4-year window.
The SELECT trial was arguably the most important data release of the decade. It provided about 4 years of follow-up. The study demonstrated that weight loss was maintained at approximately 10% over that 4-year period, proving sustainability.
But the most crucial finding was the hard clinical endpoint.
It was. It demonstrated a 20% reduction in major adverse cardiovascular events, may in people with obesity, but without pre-existing diabetes.
That establishes semaglutide as the first obesity pharmacotherapy to demonstrate a clear cardiovascular benefit, which moves the treatment beyond aesthetic management and into the realm of major disease prevention. What were the long-term safety findings?
Overall, the safety profile was very reassuring. The serious adverse event rate was actually lower in the semaglutide group compared to placebo. However, there was a predictable finding: a slightly higher proportion of participants who experienced gallbladder-related disorders.
But no other major alarms over 4 years.
Importantly, there was no difference in the percentage of participants with acute pancreatitis or malignant neoplasms between the two groups, which eased some earlier concerns.
Let's address the risk inherent to rapid weight loss itself, regardless of the drug used. The faster the weight comes off, the more intense the monitoring needs to be.
Exactly. Rapid weight loss, whether from a drug or surgery, raises concerns about cholelithiasis, micronutrient deficiencies, and critically, loss of lean muscle mass. The mitigation strategy is clear and necessary. Adequate nutrition with an intense focus on sufficient protein intake and structured resistance exercise are mandatory to preserve lean mass.
This brings us to the logistical and systemic challenge. These drugs work like surgery, meaning millions more people will be eligible for highly effective treatment. This shift in capability means the entire support system has to evolve or break.
It's a system shock. The availability of these therapies will inevitably increase the workload on specialist obesity services exponentially. To meet this massive increase in demand, prescription and management must shift from specialist services to primary care.
And that requires a huge investment.
A substantial investment in training for general practitioners and the development of sustainable, integrated care models.
This isn't just handing out a pill. Primary care physicians need to be trained on titration, nutritional monitoring, and knowing when to refer to a specialist, for instance, for a patient needing gamargomaba.
Correct. The focus of the multidisciplinary team will dramatically shift. Instead of endless discussions about starting diet and exercise, the focus will become similar to post-bariatric surgery care: intensive nutrition support, structured exercise guidance, and ongoing behavioral support.
And finally, the cost and access barrier. If these treatments are lifelong, how do we address the financial implications on a global scale?
This is perhaps the largest non-clinical hurdle. Since obesity is a chronic disease requiring lifelong therapy, the cost-effectiveness and insurance coverage become paramount. Current pricing models are not sustainable for treating 650 million people.
So we have to find a way to make it affordable for long-term use.
We have to. Research must continue into maintenance dosing strategies, using lower doses or dosing less frequently, that can sustain weight loss with lower cost and burden. If we have the cure, but only wealthy nations can afford it, we have failed the mission.
To synthesize this incredible deep dive, the pipeline of obesity pharmacotherapy, encompassing dual, triple, oral, and specialized non-hormonal agents, is fundamentally reshaping obesity management.
It is moving efficacy levels very close to, and in the case of the triple agonist retatrutide, matching the efficacy of bariatric surgery. The new bar is set by the dual GLP-1/GIP tirzepatide, achieving up to 22.5% weight loss, and etatrutide, pushing the boundaries even further with up to 24.2%.
And the availability of highly tolerable oral agents like orforglipron addresses essential barriers to access and adherence for chronic care.
Exactly.
And the future of this field lies definitively in personalized medicine.
Indeed. The new era allows for true therapeutic nuance based on comorbidities and patient tolerance. We can select drugs based on desired specialized benefits, using glucagon coagonists for liver fat, or integrating bimagrumab to build lean mass. This level of capability is what makes this era so transformative.
Here's a final provocative thought for you to consider as you reflect on this new era of care. We now have reassuring 4-year safety data for semaglutide, showing cardiovascular benefits and sustained weight maintenance. But as the weight loss achieved by these novel pharmacotherapies approaches that of bariatric surgery, a 25% plus reduction, we must now rigorously investigate whether the full spectrum of known long-term complications associated with bariatric surgery, such as increased risk of osteoporosis, fractures, nutrient deficiencies, and even certain self-harm behaviors linked to rapid weight change, will also need to be monitored in patients maintained on these chronic pharmacotherapies.
That is a critical, emerging question. It will define the next decade of research and the ultimate long-term safety profile of this revolutionary class of drugs.